1.
Good afternoon, and thank you for joining this session of NSX Extra. The NSX Extra webinars are an effort to improve the knowledge around VMware NSX, and in this particular session we'll tackle some of the security aspects of VMware NSX. My name is Frederik Verdaagt. I am the Senior Specialist System Engineer for the Network and Security Business Unit at VMware. So the agenda of today will cover some of the aspects of the state of security, how are organizations protecting themselves with the tools at hand today. Next, we'll check if VMware can help in that aspect and see how VMware sees the security challenge and how we can improve upon that. And we'll end with looking at what's on the horizon, how doing security through virtualization can possibly improve your security posture as a whole, and how we can build upon that. First of all, I'd like to start with some numbers, and these represent the spending evolution in millions of dollars on network security equipment globally. Now we see a steadily increase here. I think we can safely say it's around 10% increase year over year, which is fine, which means that we as organizations are still heavily investing in network security and trying to stop those attacks by investing more and more. Now, in the security landscape, I think we can safely say that there is a war going on, a war with, on one hand, the investment in network security equipment, and on the other hand, the actual breaches, the actual attacks and malware and hackers out there. And when we take a look at those numbers for the same years up until 2017, we also see an increase, but it's a lot more steep than the way we invest in network security. So as a conclusion here, we can say that while we still increase in buying and implementing more and more network security equipment, the number of breaches is exponentially higher year over year. So my thought on this is, while it's fine that we invest in network security equipment, perhaps there's another way of doing security. There's another way of looking at security, and perhaps there's an improvement necessary on how we tackle these challenges. So with that, I'm adding some more context on what organizations are actually investing in. And what they are investing in is network security equipment as far as network security goes, obviously. And when organizations tend to look at the market, they will typically end up with a top 3 of security vendors represented here. And while there are a lot more security solutions out there, when looking at network security equipment, these are typically the 3 that are up at the top list of security vendors. Now, what they are investing in is typically network security appliances. Those are boxes. They have a physical form. They have a strategic, if all goes well, a strategic place inside the network where they perform their role. These kind of boxes also come with some pros and some contras. The pros are that the organizations where you buy these boxes from are very reputable. And what I mean by that is they invest a lot of research and development in trying to make sure that you buy the exact perfect appliance for your situation. They also add a lot of intellectual property on top of those appliances to make sure that the latest and greatest attacks are being stopped at that level. So what they do very, very well. That's why they are so reputable. These boxes are also very performant. They are purpose-built. They are fine-tuned. They are built around ASICs, and ASICs is a type of computer chipset that performs X amount of tasks at a tremendous speed. So these appliances are very, very performant in what they do, and as I said, what they do very, very well. As a conclusion, we can say that these services inside your network, these security services rather, have a specialized form. You put them in a specific place in your network, close to the applications, far away from the applications, at the edge of your network, in the core data center of your network, depending on what role they should be playing. Now, because there are pros, there are obviously also contras. And the contrast in this context is these appliances, they only have a fixed point of view. What I mean by that is because they have a specific role to fulfill, they also have a specific place in the network. And they only see what's happening around them or what we tell them to do. I'll circle back to that in a second. Also because they are hardware-based, it's not so easy to scale. Typically, these devices are overscaled and underconsumed in the large sense. That's why if you, as a business, are growing and your business demands more security, that typically these devices are scaled through a forklift upgrade by adding more and more devices in your network or at the edge of your network. Because of their nature, because of where they sit inside the network, they also lack some context. Again, what I mean by that is they see what's happening immediately around them, but they don't really care where traffic is coming from and going to. If traffic is originating from a virtual machine or a physical machine, for them, for these appliances, it's just a source or a destination. They lack any kind of context of what the role of the source or the destination is, because the way they sit inside of the network. Now, what all these appliances have in common is an inherited capability, or as I would like to call, actually an inherited shortcoming, especially in the context of virtualization. Because if you take those boxes out of the cardboard box they come in, they come pre-installed. And pre-installed, typically they know what a security zone is. And a security zone is a construct that all of these appliances have in common. And the way you build policies is around these security zones. And typically this is based on a trust and an untrust zone. So again, what these appliances do very, very well is inspect traffic as soon as it goes over those appliances, coming from one zone to another zone. What they don't have is any kind of context of what happens inside those zones. But because of the nature of these appliances, because they typically act as a gateway between those zones, these appliances are also blind to what happens inside the zone. So to put that into context, on this slide, you can easily see that traffic happening within the trusted zone is traffic that is not seen by this appliance. Keep that in mind while we continue. Also, today, in a modern network, the application itself is already a network. When we think of applications, we typically think of a front-end service. This could be a set of web servers, a database servers where all the data is stored, and then some kind of logic, the actual application itself. The application itself is fed by what the front end is telling him to do and stores all data and changes inside the application in the database. So in this example, we have at least 3 tiers. Now, when we talk about security, we want to make sure that those 3 tiers are properly segregated from each other. We don't want them to talk to each other just randomly. So typically, with the tools we have at hand today, through network security appliances, we will divide them up in zones. And as stated before, if a web application needs to talk to the database, it will typically then go over the network security appliance to do inspection. When a web application, on the other hand, needs to talk to another web application, for whatever reason, it could be hacked, it could not be intended, that kind of communication, then the security appliance is blind to that traffic. So adding on top of that, another challenge is that the application itself is already a network. Furthermore, when we talk to our customers, whenever I ask the question, what is the virtualization grade you have adopted today, I have never received a number under 85%. So the workloads, the actual server workloads and the services that are running inside a data center are today greatly virtualized. Because of the nature of virtualization, these appliances, these services will talk to each other. They will also share services amongst each other, like DNS and FTP, typical network services. And all that VM to VM traffic, unless those zones are being stretched all the way to that security appliance, that's a typical security appliance is then blind to all that what we call east-west traffic or VM to VM traffic. So with all of that, with what we just have learned, the fact how security appliances work, how they inspect traffic only when traffic passes over them, the fact that our data centers are highly virtualized, the fact that a network itself, an application rather, itself is already a network, all that are variables that allow our customers or organizations in general to build a data center network. So how are they built? On top, we have a set of racks or a set of servers that represent the virtual infrastructure. So this is your ESXi environment, if you want, represented by these services, by these servers. We call this the compute layer. Now, all of these servers, they need to talk to each other independently and accordingly. So some network equipment needs to be inserted so that they are able to talk to each other. And the first layer of networking equipment is typically the switching layer. This is represented here by the TOR, or the top of rack switch. You can imagine that this is a simple switch sitting in the same rack where all your ESXi servers are sitting. Now these switches themselves, they also need to communicate with each other, because if, in this case we have 4 racks, if a packet is originating from the first rack and needs to go to the 4th rack or the 5th or whatever, it will not be sitting on the same switch. So there is another layer of switching inserted, and we call this the aggregate layer. Now switching is fine. Switching is a layer 2 technology, which allows you to segregate your network in different VLANs, in different subnets. But we just established that an application itself is already a network, and in order to segregate them from each other, yes, VLANs is a perfect technology, but at a certain point in time you need to traverse VLANs, so routing needs to be inserted. In a typical network, this is represented by what we call the core routing layer. This is typically also the place where you will insert security because of the nature of the appliances. They typically are a gateway between all those zones, VLANs, subnets that reside within your data center network. Now, when we copy this to how VMs communicate with each other, we draw a dire picture. In this example, I have a blue VM and a green VM. They represent an application VM and a database VM. At a certain point in time, they need to communicate with each other because the application has learned something and needs to store that in the database. Now, what happens with the technology at hand is that the application VM sits on a switch and needs to traverse the entire network to have a certain routing decision, to learn where the database server is. We also want to do this securely, so we stretch that traffic over an existing firewall where the security policy is then enforced. Fine. As soon as the security policy allows us to talk to each other, the traffic resumes and travels all the way back to the VM. Now, in this scenario, those two VMs were sitting on the same hypervisor. They share the same hypervisor, the same virtualization layer, and yet, in order to talk to each other, they need to traverse the entire network. Now, is this a problem? Yes and no. Modern networks have tremendous low latency, have fantastic throughput, so the fact that they can talk to each other over several appliances, if the application allows it, is fine. What we are stating is that with VMware, because we are the hypervisor, perhaps we can improve upon that. So moving on, let's see how we envision security through VMware solutions. Building on top of that, with what we just learned during the introduction, first of all, we have a certain infrastructure, a physical infrastructure that consists of physical servers, your ESXi servers and other servers, that consists of switches, routers, firewall, load balancer, all physical appliances that make up your network infrastructure. Typically, we call this a fabric that allows you to interconnect all services that sits on top of that. Now, with VMware, we know that we insert a virtualization layer on top of that. A modern VMware infrastructure allows you to connect all your servers together to one logical layer. And whether this is done through VMware or other hypervisor solutions like KVM, or even in the cloud at AWS, the same logic applies. There is a physical network underneath and a hypervisor layer that lives on top of that. Now what we do with NSX is actually add another layer on top of that. And this layer now has all the typical network services from which we know that they typically live inside the infrastructure layer inside it. So all switching, all routing, all firewalling, all load balancing lives in this layer. You can imagine that this is a logical layer that spans across your entire hypervisor infrastructure. Now when it comes to applications, we can put our applications on top of that, just like we did with normal virtualization. And because we learned that an application actually is a network, we can start segregating them. Segregating them by putting them in logical groups, silos if you want, but let's keep it with groups. In this case, we have a white group, a light blue group, and a dark blue group. This could be representative of the application and the logic and the front end and the database servers that we mentioned before. Now, the trick here is that because in this NSX layer, this light blue layer, we provide all the switching and all the routing, the connectivity between those virtual machines is all done within the hypervisor. So in order to communicate with each other, they don't need to go to the physical network anymore to make any logical decision. All the routing, all the switching is done inside the hypervisor. So with that, we also learn that the physical infrastructure is greatly simplified because it is now only there to interconnect our ESXi servers, and all the logic, all the intelligence, the switching, the routing, etc., is done in the NSX layer. So this is true for connectivity. Of course, this is a security webinar. So let's talk about security. Because we insert a layer between the applications, the actual workloads where our applications are running, and between between the applications on one end and between the outside world, the rest of your data center on the other hand, we are uniquely positioned to do security. Now we have a common layer, a common logical layer across all your applications that enforces security per whatever policy you want to define. So how do you need to envision this? Every virtual machine that needs to talk to every other virtual machine or the outside world needs to go through this layer. Remember how we do security in the physical world. If you want to enforce a policy, you need to traverse the entire network to a specific certain security appliance and then come back. Now, these services live inside the hypervisor on the virtualization layer, so we don't need to consult the physical anymore. That means that actually we now have a firewall, if you want, per virtual machine. And because every virtual machine, whenever it needs to talk to another or the outside world, needs to traverse that layer, a firewall can always be enforced. Now, a firewall can be unique per virtual machine. In this case, we see that the white VM is firewalled for traffic coming in and out the data center, but it can also be adopted as a segmented approach where your multi-tiered application is properly secure from one another. So that traffic coming from, let's say, the front end to the database is properly firewalled, and that only the virtual machines which make up the application that are allowed to talk to each other should be able to talk to each other, and not just everybody to everybody. This is, of course, the concept of what we call zero trust, and I'll come back to that in a second. So there are some benefits of virtual security or security virtualization. The first of course, is unlimited scale. The scale goes hand in hand on what kind of resources you have available. So because VMware NSX sits in the same kernel as VMware ESX, the kernel you already have, we don't require you to buy more hardware or more specific switches to make this happen. No, we just share the same kernel which you already have. So that also means that If your business needs to scale, you will need to scale that kernel anyway, because you will need more resources from the virtualization platform in the first hand, and it's the same virtualization platform that we repurpose basically to do security as well. So the scale goes hand in hand with the demand of the business, which is in contrast, of course, with the legacy appliances where forklift upgrades are necessary. As I said before, this is also the zero trust approach. So unless the policy exists that workloads are allowed to talk to each other, they will never talk to each other. This is a whitelisting approach, where you say that certain applications are allowed to talk to each other, and all the rest, all the other kind of network traffic is impossible. Which is different than the traditional zone-based approach, where you define specific zones, but what happens within that zone is something that the appliance doesn't see. Here with NSX, we see any kind of traffic, regardless of where it's coming from or going to. We also add a lot of context. Because we are the virtualization layer, we do not only need to rely on something like an IP address, something that the legacy security appliances typically do. We can, if you make a firewall policy, you will still need to define a from and a to, a source and a destination. Now, in the context of virtualization, that source can be anything that is definable by a virtual attribute. Virtual attribute could be the VM name, the guest operating system name, the patch level, what services are running, which ports are being used by which specific services. So it goes much, much deeper, much more granular than what you can do with a legacy network security device. It also improves your asset utilization, because when you do security properly, as close to the application as you can with NSX, you can now start thinking of pooling resources. Because when I talk to customers, I typically have the argument of something called air gapping specific services. Now, when you share a common virtualization platform, and you can still make sure that workloads are not allowed to talk to each other, even though they share this common platform, there's no real need for air gapping anymore. You enforce the security posture within the hypervisor and not relying on any physical attributes anymore. It goes hand in hand by saying that this simplifies the management, because we now have a single pane of glass, a single common infrastructure that allows us to make the policies as we grow, as we go, which is very different when you apply multiple vendors inside your network. For instance, we see a dual vendor approach typically, where at the edge of the data center you put some firewalls in place, and then in the core of the data center you put other firewalls in place. This is fine, this is a very good approach, but it requires you to manage multiple central management of the specific vendors that you choose. While with VMware NSX, you have a common platform on which those services can also sit, and I'll come back to that in a second, but it allows you to centralize that management greatly. Another benefit is the rapid deployment or change of applications, as opposed to waiting on the security team to change a specific firewall policy. Why is that? Because the enforcement is happening inside the hypervisor. It travels along with the virtual machine. So again, this is a zero trust approach, and if you put a new virtual machine on a zero trust platform, it will not be able to communicate. So it is by nature, by design, secured from other workloads. Unless you define a policy, at that point, they will be able to communicate. So security at the get-go, security as soon as you provision a new application, and not just as an afterthought. It goes hand in hand with the portability of the application. All these services that I mentioned earlier are distributed. What I mean by that is that a switching service on VMware NSX, or a routing service, or a load balancing service, but in this particular case, the security service is distributed. That means that no matter where the virtual machine moves inside your data center, and even now when we stretch that knowledge across public clouds towards public cloud, the security posture around that virtual machine will always remain intact. And that's a great benefit. The mobility of your applications because traditional appliances can only see as far as the networks to which it is attached. Now, what's next? So what we have covered is that NSX provides connectivity, correct, and also security. The security that it brings to the table is a stateful layer 4 firewall. What does that mean? That means that it knows, according to the policy, if a certain network port is open or allowed to accept traffic or not. That's what it knows. This is what a traditional firewall can do as well, only of course not in a virtualized way or in any distributed way. What I'm trying to say here is that a typical firewall, a port-based firewall, a layer 4 firewall, is perhaps not enough in a data center, in a modern data center. In a modern data center, you typically require further inspection. And while we provide the layer 4 firewalling, you could consider this as the perfect place to start scrubbing unnecessary traffic. But what about the traffic we allow? We also want to see what's going on inside those information flows. For instance, where do we do antivirus? This is not something a traditional firewall does. Where do we do intrusion prevention or vulnerability management? All those things typically live on what we call layer 7 instead of layer 4, so a bit higher in the stack than what we are accustomed to. So let's cover that. So yes, it's true, security virtualization through VMware NSX provides a firewall, a layer 4 firewall. And yes, that is not enough in a modern data center. So while we provide the distributed firewall, we are also the platform on which third-party vendors can bring their solution on top of. Now, remember when I said that all the services that we bring to the table with VMware NSX are distributed. By that, again, I mean that they travel along with the virtual machine no matter where it is. This is also true for these third-party applications. So imagine that you choose one of these vendors listed here because they have a very good scanning engine or because they are the best in finding vulnerabilities. They all have an integration with NSX. And as soon as they bring their IP, their intellectual property, on top of NSX, they become a distributed service that you as a security administrator can easily consume. So this means that not only you can properly firewall virtual machines from one another, you can now also properly do layer 7 inspection between virtual machines. Coming back to the discussion, it's a one-way discussion, but the topic I had earlier is where certain organizations choose for an air-gapped approach. Now, when every virtual machine inside your organization is properly protected all the way up to layer 7, you don't need to have that air-gapped discussion anymore. Also, the discussion around a DMZ, a zone in which shared services lives, becomes a mute discussion, because every virtual machine now in itself is its own DMZ zone by bringing the layer 7 all the way to the virtual machine. Now, how do we do this? First of all, when I say that every virtual machine comes with its own firewall, that could be comprehended as if I have 100 virtual machines, now all of a sudden I need to manage 100 additional firewalls. Nothing could be further from the truth. As I said, these services are distributed. It's one logical layer, so the way you manage these firewalls is, or firewall, is as one big firewall for your entire virtualized data center. So what we do is we try to make your life easy by introducing what we call the service composer. And the service composer is a management attribute within VMware NSX that allows you to specify what you want to protect, and that what could be based on virtual machine or virtual machine name or any attribute that makes an application or a set of virtual machines unique. So first of all, we define the what, and then we also define the how. And the how is listed here on the right through the services profile, where you simply say, okay, I want to have communication between these VMs or set of VMs. I want to do firewalling, I want to do antivirus, I want to do APS, vulnerability management, etc., etc. This is where you define your policies. It's a very easy approach in building a security posture inside your virtualized data center. Now, another way of looking at this is through what I call, it's not my name, the Venn diagram. I didn't invent it. It's very old. But it's a very easy way to understand how policies are being built. So the Venn diagram, the concept of Venn diagram in this case is that we have 3 circles, and where they overlap, they need to share services. So first of all, we're going to define what we want to protect. And in this case, we have the white circle that represents our Windows machine. We can fill this group up dynamically by simply saying, if the guest operating system is Windows, you belong to this group. So the dynamic nature of filling that up. In the red circle, we have all our web servers. How do we define that those are web servers? Also, this can be done in an automated fashion by saying, if a virtual machine listens on port 443, then we know that it's a web server, so it belongs in that group. In the green circle, we have our compliance systems. Now, this is very hard to learn from network traffic or by looking inside a virtual machine. This is something that we need to enforce ourselves. We can do this through what we call security tags, and security tags are nothing more than stickers, basically, that you put on top of virtual machines by saying, well, this virtual machine needs to be PCI compliant. Now, filling up those zones is very easy. Now we need to define policies linked to those zones. So the white circle could have a policy that says, allow DNS, allow Active Directory services, allow sharing of files. When a virtual machine sits in the overlap between the white and the red, it adds allow HTTPS because it's also a web server. Now, this is a Windows machine rather, that is also a web server. But as soon as it needs to be compliant, we start blocking certain services. And all of this can be performed in an automatic way by, first of all, applying the tag, but all the rest underneath is done automatically. It makes sure, VMware NSX makes sure that you end up in the right security group, and because you end up in a certain security group, the right security posture, the right security policy rather, will be enforced for you. So a very easy approach to managing an entire virtualized security posture. Another concept of this is visibility. Now, when I say that we add an extra layer between the applications and the virtualization layer, where we're going to do firewalling, that also means that now we are doing firewalling or security as a whole, where we typically did not do firewalling before. So coming back to my introduction, when you take a look at legacy network security appliances, they know what a zone is and they will enforce security strategies between those zones, but they are blind of what's happening inside a zone. Now with VMware NSX, we can firewall and properly secure VMs from one another inside a zone, but the challenge is, since I did not do security before, hence I did not know how they were talking to each other, how am I going to build policies? So this is where NSX helps you with, through the rule creation with the application rule manager, or short ARM. What it does is it visualizes the actual network flows, the network traffic, the ports that are being used, also the services that are responsible of creating those network flows amongst each other. It will visualize that for you, and it will allow you to make a rule on what we actually see happening inside the virtual world. So if two VMs were talking to each other, and we did not see it because of the nature of our physical network appliances, with NSX you now get to see how they talk to each other, and based on how they talk to each other, we can easily create firewall rules to make your environment even more secure. Now it doesn't stop there. This is an aspect of NSX that comes with a product. Another product that we have is called vRealize Network Insight and goes much, much further. It visualizes all traffic between virtual machines, but also visualizes how that traffic is transported over the physical layer. So as I said during the introduction, you have a set of ASXi servers. They are interconnected with each other through a set of switches, through a set of routers, perhaps through a set of firewalls. This is typically what this product, vRealize Network Insight, will visualize as well. This will greatly help in troubleshooting when something goes wrong, when there is a problem with the virtual switching or the physical switching. It will alert on top of that, and you can take action on top of that. Again, it doesn't stop there. Because we have those insights, it does a similar thing as the ARM, as the application rule manager, by looking into intra-zone and intra-VM traffic and making recommended firewall policies based on the traffic that it sees across the board. So it goes much further than what comes with NSX natively through ARM. Another approach of providing security is, I've been talking about servers and services, web servers and database services. Now, VMware infrastructure can also be leveraged for virtual desktops. That means that all of a sudden, virtual desktops are now running inside your data center, beyond the perimeter, beyond the edge of what was typically secured inside your data center. Desktops also, they are very prone to attacks because of the nature of the operating system that's running in there, and because they are operated by human people, they can be prone to attacks. That's why VMware NSX is such a valuable security solution in this context, because now with VMware NSX you can properly firewall those machines from one another, so they are not allowed to talk to each other. Because you need to know that when a hack occurs, or malware, or especially worms in that nature, the first thing that they do is, after a successful breach, they will start spreading laterally across your data center. In order to stop that, a firewall per virtual machine is required. The benefit of this is that the firewall runs outside of the virtual machine. So the virtual machine itself does not even know that it is being firewalled, because it runs inside the hypervisor. That's represented by the firewall icon here. The blue icon represents the third-party integration. So every desktop itself can be inspected through layer 7 services for viruses, malware, in general, intrusion detection and vulnerabilities as a whole. So every virtual machine, every virtual desktop in this context is properly secured from one another. One step further, in this context, because we are the hypervisor, we can also see who is logged on to a virtual desktop. So the way these virtual desktops are typically being consumed is through a broker. In our case, it will be the Horizon VDI broker or the connection broker. We can easily see who is working on that specific virtual machine. Now, with that knowledge, we can add context to our security postures. Because if I log in into a virtual desktop, I will have access to X amount of services across the network. If I log out and somebody else logs in with a different role inside the organization, I would hope that the security posture around that virtual machine changes dynamically according to who has logged in. And that is typically what VMware NSX brings to the table as well and adds when it comes to security. So we don't only firewall it, we also act as the platform for layer 7 inspection, and we also do role-based or user-based firewalling. Building on top of that, the virtual desktops themselves can be consumed through a broker, but there's also the aspect of end-to-end security. And by end-to-end security, I mean that typical data center services are no longer being consumed, or more rarely being consumed by a desktop. They are being consumed by our mobile devices and our tablets and such. With VMware, we provide the technology to properly manage those devices in a secure way. But with NSX now, we also provide a way of connecting per user, per application, a way to the back end where the applications live. So this is a very granular approach, and this allows you to make very granular security strategies for all your users and applications, as well as the back-end applications end-to-end. And it doesn't stop at firewalling. We also provide the actual tunneling between the mobile device and the back-end applications through either IPsec or SSL tunnels, all governed from within VMware NSX. Now, all of what I've been saying is true for an on-premise data center, a data center that you own and operate, which is fine. But we all know that typical workloads will no longer only live in the on-prem infrastructure. Typically, customers and organizations as a whole are looking at the public cloud to have their services running. One of the things that's keeping organizations back is the fact that they can't do consistent security of applications that are running on-site against those applications that are running off-site. So what customers really are looking for is when they build a security strategy around a specific application that runs within their data center, they simply want to pick up that application, have the security and the connectivity intact, and place that in the public cloud. Now, this is very hard to do because in the public cloud, we are not or no longer the hypervisor. Simply put, we can hardly control what a virtual machine, be that virtualized on Amazon or Google or Azure, can do, because we no longer are the hypervisor. We can't control the virtual machines anymore. However, with NSX, we have adopted an agent-based approach to this, and with our technology partners, Amazon, Azure, and Google, we can easily provide consistent security of applications or workloads in general that are running on-prem or in the public cloud. And this is a tremendous gain for customers that are looking to adapt the public cloud in a secure way. Lastly, I'd like to add something more specific. This is a new technology that we have launched at VMworld in October-November timeframe last year, and it's called AppDefense. Now, a lot of the security technologies that I've mentioned before, they have a few things in common, and one of which is that they all rely on a more or less signature-based approach. What I mean by that is that a certain hack, a certain malware, a certain virus needs to be known upfront in order for that specific security vendor to stop it, to keep it out of your data center or stop infecting specific virtual machines. And yes, those security vendors, they all try to challenge themselves by adding more technologies like sandboxing technologies, where they exploit certain executables and see how they act inside a virtual environment. And that's fine. That's all security vendors are helping each other. They also have the sense of community by looking at a certain infection, and if something occurs, that is then shared with the community, so others are quickly updated of that fact. So they don't run behind certain updates, and all that is fine. But the fact is that they rely heavily on signature-based, and that is saying the same thing as relying on something that is known. They are looking for the known bads. What AppDefense does is not looking at the known bads, but investigating the known goods. And because we are the hypervisor, we are in a unique position to do so. So what we actually do here is three things. First of all, we look at the intended state of a virtual workload. The intended state is the state of a virtual machine before it is actually running, right? So how do we know what this virtual machine is going to look like? Well, we look inside our own vCenter, we look inside our own vSphere, we look inside provisioning tools like Puppet and Chef and Ansible and others that can tell us, well, if I provision this virtual machine, then I will launch this service, and this service will listen on port XYZ, and this is how it interconnects with other virtual machines. We know this because of those provisioning tools. They can help us learn how the virtual machine should be intended to work before it is even running. Now, we take that ledger, we take that knowledge, and we keep that in mind. At a certain point in time, the virtual machine will go live, and then we are in what we call a running state. And at that point, we do a constant runtime assessment, seeing if the virtual machine is still running in accordance of what we thought was the intended state of that virtual machine. Okay? Now, because we are the hypervisor, we can do this without touching the virtual machine. we can see what's going over the wire. We can look into network traffic, all through inspecting what is going on the virtual wire. Also, and that's then independent of the virtual machine, of course, also to look inside the virtual machine, we need some kind of agent. Now, the agent itself runs in a secured enclosure, which is tightly connected to the kernel space where we do the initial inspection as well. So simply put, as soon as that agent is being compromised, we know that something is going on as well. But we do require that agent for further insight. But it does allow us to see if services change, if admin rights change, if certain privilege escalations are occurring, if certain services all of a sudden are listening on different ports for whatever reason. We see that because we knew the intended state, and it is now being changed to what we see in the runtime state. As soon as that happens, we come to the third part of it, which is the remediation part. Now, again, because we are the hypervisor, we can easily remediate how a virtual machine is working. The simplest form is shutting down the virtual machine. Now, if it was the intention of the hacker to perform a DDoS attack or a denial of service attack in general, let's say he was successful if we, as a remediation, shut down the virtual machine. Of course, there are other remediation tools like VMware NSX that can say, okay, I change now the security posture around this virtual machine because a new service is inserted and it was validated as part of the workflow of the developer. Because also part of the remediation is warning the developer or the owner of the application, dear developer, I now see that something has changed. Is this part of your workflow, yes or no? If it is, we change accordingly. If it isn't, we can simply block it. So this is an entirely different way of looking to have threats stay out of the data center by looking at what we know is good and expecting that all the rest is bad. So this concludes our session. To summarize, I would invite you to engage and learn on the links I have shown here. You can find a lot of NSX resources on vmware.com/product/NSX, or connect with your peers through the community channels that we have, or also the blogs that we provide. If after this session you feel a certain tingling sensation in your fingers and you want to get your hands dirty with VMware NSX, I highly advise you to go to our hands-on lab, where almost all of the scenarios that I've presented here are available to you to start working with, start testing out. If you want to even take it a step further, I advise you to take some training and certification also provided through VMware. So with that, I'll see if there are any questions, and I don't think there are. If not, there's still time to post your questions in the Q&A panel that you have available. I don't see any immediate questions being posted. So I think we can conclude this session. If tonight you can't sleep and you still can think of a question, don't hesitate to reach out. We will make sure that you have a copy of the presentation, and on the first slide you have my email address if you have specific questions. So thank you for your attention, and I hope to talk to you soon. Thank you.